pistachios are a relative newcomer to the California agricultural landscape, with the first commercial harvest reported in 1976. When trees in a well-managed orchard receive optimal amounts of water and nutrients and protection against pests, each tree will respond with bountiful harvests.
Agronomists and researchers have devised a management approach for optimizing applications of nitrogen to crops to minimize leaching of excess nitrate while optimizing crop production. The approach is called the 4 R's: the right rate, right time, right place, and right source.
A fundamental point to remember, in a pistachio orchard, any source of nitrogen applied as a nutrient to a crop can convert to nitrate. If conditions are right, nitrate can eventually leach beyond the root zone and into underground aquifers. So a key component of the 4 R's is the right amount of nitrogen. Research has shown that on average, an orchard needs about 28 pounds of nitrogen per acre for every 1,000 pounds of marketable yield, and about 20 to 30 pounds to account for any vegetative growth.
The tree takes up nitrogen throughout the growing season, starting at leaf out and continuing up to harvest.
To help understand how to effectively manage nitrogen applications, you need to make sure you understand the different forms of nitrogen in the soil and how nitrogen is taken up by the tree. There are basically 3 forms of nitrogen in the soil: soil organic matter, ammonium, and nitrate. Soil organic matter is the nutrient storage bank in your soil. In the short term, organic matter nitrogen is tied up in big, complex organic molecules that are not immediately available to plants. But over time, this organic matter breaks down and provides a steady supply of ammonium and nitrate to the soil and roots. Ammonium and nitrate are the forms of nitrogen that roots can take up.
Being positively charged, ammonium can stick to soil particles, which are predominantly negatively charged and hence does not leach easily. Nitrate is the other form of nitrogen that roots can take up from the soil. However, nitrate is negatively charged, so it cannot stick to soil particles, making it susceptible to leaching. Keep in mind that a pistachio tree is regulating its nitrogen uptake since there is an energy cost to the tree to take up nitrogen. If we apply more than a tree needs, it's not going to expend extra energy to take up or incorporate nitrogen that it doesn't need.
Translated to a management practice, this means spoon feeding or applying smaller amounts over multiple applications. The more split applications, the better.
Now let's talk about the right time. Applying at the right time is about matching the timing of the tree demand with root uptake. When we look at the growing season between leaf out and harvest, April, May, June, July, and August, it gives us an idea of how much nitrogen will eventually become 1,000 pounds of marketable yield.
What our studies found was nitrogen uptake can differ if a tree is in an on or off year. In an on year, uptake is heavier during nut fill, and in an off year, the overall uptake rate is lower.
One of the best tools to guide your decisions on the right amount and right time is through leaf analysis.
The University of California recently completed supporting research for leaf samples taken in May. Having the results early enables growers to react quickly by either holding off on additional applications if nitrogen levels are adequate or adding fertilizer if a deficiency is apparent.
So where is the right place to apply nitrogen fertilizers? Typically, the vast majority of important feeder roots are in the top 3 feet of soil. So it's in that upper zone where you want to keep your water and nutrient applications. The right source is about preventing the applied nitrogen from converting too quickly into nitrate and leaching beyond the roots.
There are many nitrogen fertilizer product options.
Calcium nitrate is a readily available form of nitrogen, but also has a high leaching potential. This leaching potential can be managed with well-timed applications, and calcium nitrate is well suited to fertigation systems. Urea ammonium nitrate, UAN, is very popular due to its solubility. The mixture of nitrogen forms makes this a slightly less leachable form of nitrogen, although in warm spring and summer conditions, the conversion to nitrate is very rapid.
Following these steps will go a long way toward increasing your nitrogen use efficiency and decreasing nitrate leaching to groundwater. Best of all, it ensures you get the most value from an expensive crop input. And in this farming economy, we all want the best return on every dollar invested.